Okay, this is another interesting one. Logic function implementation in the circuit shown is, we basically need to get an expression for the f which justifies the input combinations. Remember, this is an exclusive OR gate. Those of you who are not familiar with exclusive OR gate, the property of the exclusive OR gate is that the output is just simply going to be 1 when number of ones are odd. If you look at the input, and if the number of ones are odd, the output is always going to be 1. Now, if you look at this exclusive OR gate, there are 3 inputs to it. 1, A, and B, right? 1, A, and B. Now, for 2 possible inputs, there could be 4 possible combinations. Either both are 0, or 1 is 0, 1 is on. The 1 is 1, 1 is 0, or the both are on, right? Now, if you take this right here, we have 1 input that is high, 2 inputs that are 0. Number of ones are odd. Well, this is the case. Number of ones are odd. 1 is considered as an odd number, so the output is 1. If you look at over here, the second combination, we got 2 inputs that are high, so that makes an even, so output is 0. Again, same thing. 1, 1, 2 inputs are high, makes it even, output 0. But if you look at the last combination, the number of ones are odd, and that makes it 1, right? Now, we need to get an expression from this truth table for f, and we can do it 2 ways. And I want to show you both ways of doing it. One, we can either use it doing SOP, which is a sum of product. The other one is through the product of sum. If I do with the sum of the product, I know, and I'm going to do it as a function of A and B because the other input is just high at all times, right? I don't need to consider that. So A and B, A0, B0. So the product, basically take a product, and 0 in SOP is considered as A bar or B bar or whatever the variable name is. 1 is considered as A or B or C or D and so on. So that makes A bar, B bar, A bar, B bar. We only look at ones. For SOPs, we only look at 1. Remember that. These are the min terms. There's another input output that is high. For this combination, A is 1, B is 1. So the equation becomes A, B, because how do you treat ones in SOPs? Those are just A or B or C or whatever, right? Now you could do it a little differently using the product of sum. Both equations here, the second one we need to still establish that. Both equations are going to provide you the same output. It's just 2 different ways of doing it. If we imply POS, this will be a product of sum. So we look at 0, which are also referred to as max terms. These are the max terms. So if you look at the output function, and for the function you only look at 0, which is this and this, and you look for the values of A, B. Here A is 0, B is 1. Well, things work a little differently in POS settings, okay? In a POS, when a variable is 0, it's considered as A. Opposite of how it is treated in SOP, right? It's A, not A bar. And it could be anything, A, B, D, whatever. Similarly, 1 is treated as A bar or B bar or whatever the name of the variable is. Now here A is 0, so I'm just going to put it as A, and it's a product of sum. So we are going to add the 2 variables, A plus B bar. Why B bar? Because B is 1 and 1 is treated as A bar or B bar in POS. So A plus B bar. That's one sum. Now we have another max term which is here. This time A is 1, B is 0, which means A bar plus B. And that's it, because there were only 2 max terms here. And therefore, this is a product of sum. The 2 terms are basically a product, correct? Sum of product, we have 2 products and we sum them. These 2 equations are going to give us the same output.